agree with your team and let me know your schedule. So we know how to meet up with the hours we've lost, also, and how we can plan to finish up what we have to do. Okay, thank you very much. So let's see what we can do today. Since I've known is online, and let me know whether tomorrow works too. We'll do something tomorrow. Anytime you feel that you don't have anything, we can optimize it. Because when we finish this one, Professor Sheku will take over. Okay, the earlier you finish, the better, so you can have your time to do your thing. Because by being online, you guys are big students. It's not like undergraduates. Okay. Let me see if I can share the slide I have here. So at the end, I'm going to share this slide with you. I'm going to share it with you, with Victoria. Okay. Okay. My name is Anita, Dr. Anita. So I think I want to be addressed as that. All right. So today we'll be talking about terpenoids. Terpenoids. Terpenoids is a class of natural products. These terpenoids, from terpenoid, we have terpenes, which are essential oils that does not have oxygen. Then terpenoids are those that have oxygen. So whenever we're talking about terpenoid as a cause, we are talking about both essential oils that have oxygen and those that does not have oxygen. So we're going to look at them. Remember, essential oil is that component of a plant, that essence, okay, is essential because it's not much, it's not common, and it's always concentrated essence of that plant. Essential oil is the aroma you feel when you're boiling your lemongrass. Essential oil is the smell you feel when somebody cooking original buffet, goat meat. So essential oil is the fragrance. That's also, we can use them as fragrance, the medicinal aspect of this oil. And they are concentrated, as I said. Those are the ones that you cannot use ordinarily. You have to dilute them because they are concentrated. Okay? So this course will be handled by myself and Professor Asekunowo, who is the current dean of the Faculty of Physical and Earth Science, which is newly created. So it's formerly Faculty of Science. Now it has been splitted into 3. So he's now the head dean of Faculty of Physical and Earth Science, which is where you belong to. So terpenoids are natural products derived from mevalonic acid. Mevalonic acid is the natural starting point of essential oil. Okay, it's like the backbone of terpenoids. So whenever you want to obtain any of this terpenoid by extraction or biosynthesis, we are going to start from mevalonic acid. Mevalonic acid pathway is always a pathway used in deriving most of the essential oils. Okay, and these essential oils consist of isoprene units. Isoprene unit is the unit of all essential oils. So every essential oil are made up of isoprene units. So the higher the essential oil, the higher the number of isoprene units. So isoprene unit is a compound that the carbon 5 terpenes. Okay, so when they contain oxygen, like I said, they become terpenoids. So this oxygen can be in form of alcohol functional group. It can be in form of carbonyl. Carbonyl are your aldehyde and your ketone. They can be in form of esters. They can be in form of ethers. They can be in form of carboxylic acid. Okay, so whenever you're talking about terpenoid, you look at this essential oil. Do they have alcohol or do they have carbonyl? Is it ester? Is it ether or carboxylic? These are functional groups that have oxygen in them in organic chemistry. So the presence of this functional group in terpenes makes those terpenes terpenoid. These terpenoids are divided according to the number of their isoprene units into mono, sesqui, di, tri, and tetra. Okay, mono is whenever we have single isoprene units, that is 2 mole of isoprene units. We talk about monoterpenoid. So when I have 3 isoprene units, I call them sesquiterpenoids. When I have 4 isoprene units, so we talk about diterpenoids. When you have six isoprene units, talk about triterpenoid. Remember, tri came before, after sesqui. So understand them, and maybe when you ask in the exam hall, you come and mobile up and say after mono is di, after di is tri. No. Mono sesqui before di and tri. Then tetra. Tetra are the ones that have isoprene units of 8. They fall in the class of carotenoid. Carotenoids are what gives your carrots its orange color. So that is tetraterpenoids. Okay, then when they are higher than 40, we call them rubber. Remember, there are some plants. Rubber is from plants. So these plants are these rubber are terpenoids. Okay, but they're higher terpenoids. That's why they are very strong. You can see the mono and sesqui are where we have as essential. The higher you go, the more the terpenoids became more solid. Okay, they are not more like oil, just like talk about rubber. Okay, now if I'm fast, please raise up your hand and tell me to slow down. If you don't understand anything on each slide, don't ever keep quiet. Okay, so that whenever we are done with the slide, we know we are done with the slide. Okay, so we have monoterpenoids, we have sesquiterpenoid, we have di, we have tri, and we have tetra. So make sure you know all these ones. C1 and to C mono and sesqui are the essential oil. They are the ones that have aroma. Okay, when you're cooking your lemongrass, whenever that lemongrass start boiling and the essential oil in the leaves start breaking forth, they start evaporating, start smelling it. So that is the aromatic essence of that plant. Okay, now beta carotene is a pigment in carrots, and from this beta carotene is going to be synthesized to vitamin E. Okay, vitamin A. And that's why they said carrot is good for the eyes. Because when you take in carrots, what you're taking in is beta carotene. And it is going to be biosynthesized in the system to form vitamin A, which is utilized for your eye health. Now, lycopene is that pigment in tomato. So that is what gives the tomato the health benefits we are talking about, is the lycopene. So whenever you look at tomato, you look at the color of tomato, what comes to your mind is lycopene. And the funny thing about this lycopene is that the more you heat it, the better the essence, or the better the concentration of lycopene. So normally, as we can think, is that fruits and veggies are better when not cooked, but tomato is better when cooked. So whenever you want to get the essence of lycopene is more soluble in oil. So when you have your stew, you get lycopene. When you boil your tomato, you get the lycopene. But some of us will destroy the essence of lycopene by adding rubbish spices and plenty Maggi. Normally, monosodium glutamate, some of those things are what spoils the health benefits of a lycopene in tomato. But in absence of that, it is very healthy. So that's talk for another day. But remember, tomato is not good for every blood type. So if you're blood type B, deal patiently with tomato because it's not good for you. Okay, the blood type O can enjoy tomato very well. So let's continue. Now, in this table, we can see how these terpenoids are classified with respect to their isoprene units, the number of carbon atoms, their names, and example. Okay, so when I'm talking about monoterpene, I can talk about peligon. I can also talk about limonene. We are going to see so many of them in the subsequent slide. You just understand the number of isoprene units, the number of carbons, and the class of this terpenoid. And you should be able to talk about example of these terpenoids. Some of this example where you're going to see some other ones in the slide. You should be able to tell us the example. You should be able to tell us the structure of this example. This course, you should, whenever you're learning a terpenoid, you should also be able to draw the structure. So whenever you're reading this course, make sure you have your pencil or your biro and paper where you're going to be writing and drawing. Even if at the end of the day, you might not even read what you're drawing, but let there be interaction with your pen, your brain, and your paper. Let's continue. Okay, this is a monoterpene structure. Remember, the basic skeleton of this isoprene units, of this monoterpene is isoprene units. And the IUPAC name of isoprene unit is 2-methyl-butadiene. 2-methyl-butadiene. So whenever they want to link, remember monoterpenes or monoterpenoids, they contain 2 isoprene units. So these 2 isoprene units, which is 2-methyl-butadiene, are going to be connected to each other through head to tail method, meaning the head of one isoprene unit is going to connect to the tail of another. Okay. So if you look at them, this is the structure of the isoprene unit. You can see 2-methyl. Remember, when you want to name the compound, you go for the longest continuous carbon chain. So we have 4, 1, 2, 3, 4. And at carbon number 2, starting from my right, I have a methyl. And remember, we have 2 double bonds. That's why it is diene. 2-methyl-butadiene. Diene is 2 unsaturated double bond. Now, these monoterpenes, they contain 2 isoprene units, and they can possess oxygen-containing functional groups. Like we say, they can be alcohol, they can be carbonate, they can be carboxylic acid, ester, or ethers. Okay, and they are stereospecific, so they can be positive or negative. Okay, we have a cyclic, the one that are not ringed. We have monocyclic, the one that are ringed with 1 ring, bicyclic, 2 rings, and tricyclic, that is 3 rings. So these my monoterpenes, they can be mono, they can be 1 ring, they can have 1 ring, they can have 2 rings, 3 rings, or they will have no ring. So we're going to see an example of acyclic monoterpene, monocyclic monoterpene, bicyclic, and tricyclic. This is a isoprene unit, like we said, they will join head to tail. You can see the way they join. This is head connecting to tail of another isoprene unit, and that's connecting to the head of another, that's connecting to the tail. So they continue to head and tail combination. Okay, that's how they join. So let's go to the examples of the isoprene units. Remember, I'll say we have a cyclic. A cyclic monoterpenes, example are citral, we have mycin, we have ocimine. These are monoterpenes that have no ring. They are not covered. They are open rings. Okay. Now, citra, mycin, and ocimine. When you count the number of carbon there, the number of carbon should be 10. Count them and confirm they are 10. That's why they are monoterpenes. They are acyclic because the ring are not covered. They are open ring. Okay. Now we also have monocyclic monoterpene. These are terpenes that have only one ring. They are monocyclic, they have one ring, and their carbon atoms are 10, making them monoterpenes. Because that 10 means that they have 2 isoprene units. We have carbon, we have menthol, and we have D-limonene. D-limonene are the active of lemon and lime. That is antibacterial, antiviral potential, or antifungal property of lemon is because of the presence of this D-limonene. We are familiar with menthol. Normally, everybody wants Baba Blue because of menthol. So this is the formula of that menthol you are licking. This is the formula of the menthol you feel whenever you are chewing gum. This is the menthol you feel whenever you use hair products that contain menthol, giving you a cooling feel on your hair. That is the formula. You can see it's a monoterpenoid because it has alcohol functional group. Carbone is a monoterpenoid because it has carbonyl functional group. Why D-limonene is monoterpene because it does not have any oxygen or oxygenated functional group. If you look at ocimine, you know that it's only citra that is monoterpenoid, a cyclic monoterpenoid. Others are a cyclic monoterpene. So you should be able to know when a compound is terpenoid and when a compound is terpene. Then they are always graded as terpenoids. Now we have alpha-pinene. If you look at them, they have 10 carbons, but they have 2 structures. That's why they are called it bicyclic. They have 2 rings. So you can see alpha to June and beta to June. You can see how they are. Alpha and beta, what's different? Looking at the structure, the only thing that differs is one is in cis, one is in trans. Okay? One is in cis, one is in trans. You can see on that first carbon, one is stressed, one is dotted. So that's what made them alpha and beta. So the one that is dotted is cis, one is stressed. The one that is dotted is trans, one is stressed that is cis. So that's how we have 2 isomers of June. We have alpha and we have beta. And this is alpha pinene. If you look at alpha pinene, you can clearly see these 2 rings. 2 rings. Okay. So we have bicyclic monoterpene. So even if you said two examples each of bicyclic, when you know your June, you just know the alpha and beta by stressing one of the methyl or the first carbon, which is a methyl, stressing one and dotting the other. So you're having alpha and beta. So there are 2 structures. Now we are talking about a cyclic sesquiterpene. Remember, if monoterpene have 2 isoprene units, sesquiterpene have 3 isoprene units, meaning that their carbon atoms is meant to be 15. When you count the number of carbon atoms in phanesol, you can see that they are 15. And because they have high alcohol functional group, they are now a cyclic sesquiterpenoids. We have alpha bezabol. This is also a monocyclic sesquiterpene. It's a sesquiterpene that has 15 carbon atoms, but it is monocyclic because it has just one ring. Other ones are straight chain. So look at another bicyclic sesquiterpene. Okay, and also have tricyclic sesquiterpene. So nerilidol is also monocyclic, a cyclic sesquiterpene. Humulin is monocyclic sesquiterpene. So make sure at least from each of this class you're able to know one example, at least one example each. And if you can know two, not a bad idea. But make sure you're able to know this terpenes example of each of the classes. And make sure you connect with the past question on this 844 and understand how the questions are asked. It will help you to know how you're reading. Because as soon as lecture starts, you should start reading. Because knowing that it's a mature student class, so it's not something you will have to be expecting a timetable for exam to come before you start reading. Because you have to start reading. So when exam comes, you will not be having a crash program. Okay? So under still under monoterpenes, we have a cyclic, monocyclic, and tricyclic. Remember, we've talked about all this before. Under a cyclic, monocyclic, and tricyclic. Okay, now let's go to bicyclic. Bicyclic monoterpenes are the ones that have what? Two rings. They are bicyclic. They have two rings. And they are all still monoterpenes. We've talked about tujone before. We have alpha and beta tujone. We've talked about alpha pinene in the previous slide. This slide we're going to introduce camphin, and we are also introducing precarine. Okay, so with this, what we need to do is get a note, and under each of the monoterpene, be consistent with the ones you need to know. Like maybe the question can also be asked for a particular terpene, just like something like farnesol or camphin. You may be expected to know or draw it. But apart from that, make sure on each of the classes, you're able to write and draw at least two structures each. Okay? It will be very, very important for you to do that. Okay, let's continue. Now, on this slide, we are specific about oxygenated monoterpenoids. Oxygenated monoterpenes, which are terpenoids. Oxygenated. In the previous slide, we are talking about generally as a class of monoterpenes, and sesquiterpenes, a cyclic, monocyclic, bicyclic. In this case, we're talking about a cyclic monoterpenoids. So these are monoterpenoids that does not have a closed ring, and they are still monoterpene because they have just two isoprene units. Okay, example of them are geranol. Now, geranol and nerol, if you look at them, they are similar. Difference is that one is cis and one is trans. If you look at geranol, the methyl and alcohol functional group are on the same side. So they are on cis. If you look at nerol, they are at opposite each other. So they are on trans. And look at down. If you look down, you can see that citral, which is geranyl and neral, they are all oxidized form of geranyl and nerol. Meaning that if I know geranol, I've known neral, I've known nerol. And if I've known geranol, I've also known geranyl. And if I know nerol, I've known neral. So they are alcohol and aldehyde, which is oxidized form or reduced form. From geranyl, and when I do reduction, I'm going to form geranyl. The Y from nerol, when I do oxidation, I form neral. So they are oxidation and reduced form of each other. So if I'm expected to talk about two examples of acyclic monoterpenoids, knowing geranol, I've known 4 already. So this should not be an issue with us at all. And if you look at citronellal, and what can you see? From neral to citronellal, what differs? Simply what happened was hydrogenation. Neral was hydrogenated once to form citronellal. So they are the same compounds. So virtually are formed 5 structures by just knowing one. So that is why the consistency is the key you need to keep when it comes to 844 as a course. Consistency in reading. Remember, this course is recorded online, so you can actually go online and listen to it over and over again. Okay? So that anything you're missing, you can get it. And remember, when you listen to something over and over again, they became part of you unconsciously. Okay, so make sure no day passes without you having a cursory look at your 844 slides. At the end of each of the classes, you're going to have a classwork, which you're going to be submitting on Google Classroom. Since it's online, you have to do everything online. And make sure that all hands are on deck. When it's time for deadline and you did not submit, it means that you're calling for wahala. Meaning that as soon as whenever you submit late, that classwork will not be counted for you. It's as good as not submitted. So make sure you're punctual and up to the task when it comes to classwork and your classes, because attendance is part of it. If you have to do online, everybody must be available. And being available is not just connecting to the class and going about your own business, because I can unmute everybody and start asking questions in the middle of the class. And if I call you and I didn't get a response, it means you are not available then. Please, if anytime we are fixing for the class, let it be the class at time you'll be available to attend to the class. Thank you. Let's continue. Okay. Monocyclic and bicyclic monoterpenes. Some of those we talked about them before. Now, if you remember when we talk about menthol, and we are seeing menthone, difference between menthol and menthone. Look at menthol. What happened? Oxidation and reduction. When menthol is oxidized, it becomes menthone. So if I've known menthol, I've known menthol. So knowing one, I know two. So meaning that if I'm looking for monocyclic monoterpene, I've gotten two by knowing just menthol. I've also gotten menthol and menthol. Okay. So when we come to bicyclic, you can see we talk about tijone, alpha and beta tijone. And we look at another one, we have camphor. Okay, so knowing this, I've known all the structure once, right? So like we said, at least minimum of 2 structures from each. My camphor, my tijone, I can say alpha tijone and beta tijone. It's fine, okay? These are the structures, these are very known. And other structures, as you can see, penchone. These are the structures of bicyclic. 1,8-cinolol is also a bicyclic compound. So bicyclic, when you talk about bicyclic, you can see 2 rings in one compound. That's what made a bicyclic monoterpene. Why are they mono? Because their carbon atoms are not more than 15 carbons, meaning making them 2 isoprene units. Let's continue. These are more examples of monoterpenes. We've talked about geraniol, we talk about menthone, we talk about menthol, we talk about mycin. The only one we've not talked about here is alpha terpenin. Okay, we've talked about tijone and we've talked about carbon. The examples are so overwhelming that if you don't go and bring your paper and write them out, you'll be confused. So the first assignment we're going to talk about is bringing your and bringing a note and writing on each of the classes. Be specific about it on each of the classes. Okay, it will help go a long way so as you will not be confused. So let's talk about the physical properties of this monoterpene or monoterpenoids. Now, they are mostly liquid and some are solid. Remember, something like rubber cannot be liquid. So the lower ones are liquids, the higher ones become solid. They have melting points like alpha pinene, like minus 50 degrees. Whenever something is minus, mean that thing is liquid. Camphor is 179. They are solid at room temperature. That's why you see them as balls, camphor balls. That's essential oil. That's why they normally chase away ants and cockroaches because of their smell, the essential oils. They are 179 degrees, meaning they are very solid. For this one to melt, you have to heat it up to 179. Okay. The boiling point of alpha pinene is 156 degrees. Why that of neuralidol is 276. When something has boils at 276, means that you have to heat it before it boils. Then the solubility of this monoterpenoids, they are organic solvents. Because they are oil, they cannot be soluble in water. Now, if you know something that is eucalyptus or tea tree oil, whenever you drop them inside water, you see them as droplets, just like what happens when you put rub in water. That's what happens. Okay, they will float on water because they're not soluble. And if you add them something like alcohol, they will dissolve and the solution becomes homogeneous because they are soluble. Okay. Okay, so we talk about camphor, this structure of camphor. At this stage, you should be able to draw this camphor because we've seen this camphor several times. So you should be able to know the structure of camphor. Camphor is how many rings? We have 6 carbon inside. That's 6 rings. Then we have another ring that bisects that connects the cyst. That one is inside. Okay. Inside that inside, I have compounds. Like I have substituents on them. So that's all. It's a very simple thing for you to know. Even alpha pinene. These are simple structures you should be able to identify yourself with. I want to see the assignments. You're going to snap your assignments because you're going to snap all these monoterpenes, diterpenes, the classes, like I said, snap them and share. Victoria, make sure you create a platform, a platform on WhatsApp, okay, for 844. So we can be disseminating information there for everyone. I hope that's fine.
Okay, we have the platform already. I'll just add you to the platform.
Okay, fine, good. Thank you. Okay. The occurrence of these monoterpenes. Remember, I said these are found in plant and animal kingdom, like whenever you're preparing your buffet. If it's original, if it's not the one that they use water to take away all the essential oils. If it's a local buffet, whenever you're cooking it, people outside will know that something is happening. That smell you're hearing when you perceive when you're cooking that buffet is essential oil from that animal. Or whenever you're cooking your lemongrass, people will know that you're cooking agbo when it starts boiling. Because the essence of those plants and herbs are what smells out. So we can also still find them in terrestrial and marine plants and animals. Okay, so whenever there are some things, and whenever you touch them, they smell. That smell is what made them what they are, and that is essence aspect of them. Okay. Okay. Now, in plant kingdom, these monoterpenes are distributed in higher plants. You can see them in the roots, you can see them in the leaves, in the stem, and even see them in seed. Essential oil, you don't get it by simply extracting with oil or extracting with solvents. You get them is they have to be heated for the pore in the leaves or in the root of this plant to open up and they release the essential oil. That's why they are very small. Okay, and if you know how they are being packed, they're packed in small container because they're very small. Okay, trees exist mainly in softwood. Okay. Some of these essential oil in trees exist in softwood. Some also tropical hardwood. These are often responsible for the odor of this wood. If you go to a place where they are doing chamber, all this wood, if all those places they are selling wood, you can see that that place smells. The smell, the odor you're getting from that wood is because of the essential oil in them. Okay. They are also found in oleresin. Oleresin is a type of resin. So this essential oil are also found in them. Animal kingdom. Essential oil was used as a warning compound or something that this plant insect used to repel from intruders. Okay. Example of them is your alligators. Whenever they come, they bring out their scaring skin. Okay, and that scaring skin has some pins that whenever you touch, it smells. So that's what they're using to ward off intruders from attacking them. So this essential oil, as I say, is a volatile component released during pulping. Do you have a class now, Victoria?
Mama, I was actually supposed to be for 2 hours.
Okay, because in the next 10 minutes we'll be done. I just want us to finish monotyping so that when we come, next class we'll start with sesquip, the next topic, maybe sesquip or that. The monoterpene that is often used commercially is pine oil or turpentine oil. These are used, especially I think maybe if you talk about pine, if you go to a place like Ojota, you can be able to get this pine oil. I think they use it in paints or something. Okay, so this essential oil, anything you talk about in natural product is something that you see around you. So whenever you're doing the course, make sure you relate it with things around you. Don't just make it garbage in, garbage out. Let it be applicable in your daily life. Okay, now synthesis of camphor. Synthesis of camphor. I think we're going to end the class on the synthesis of camphor. Now, whenever we want to synthesize camphor, synthesis is essential as long as this course is concerned. So don't be scared. Just understand what happens. So we're going to go through this together and end the class on this. Now, the starting material for synthesis of camphor is alpha-pinene. Then alpha-pinene using hydrated titanium oxide at a very high temperature of 180 degrees, you're going to form camphene. Okay. Then under esterification reaction, you can see that we are having carboxylic acid. You can see we are having under acidic medium, that's why you have HS. You're going to form an ester. Okay, which under hydrolysis is going to form an alcohol, which oxidizes, that O is oxidation to form a camphor. So if you look at this, the point where the reaction is occurring is that double bond. Now, in organic chemistry, we'll talk about functional group. Functional group is that aspect of a compound that determines its chemical properties. And that is a reactive aspect of that compound. So looking at the alpha-pinene, the only functional group we have there is double bond. So every reaction occurs around the double bond until we form our camphor. Everything occurs at that point of double bond. Okay, so the first thing is your alpha-pinene, which using hydrated titanium oxide at a very high temperature is going to form our pinene. What happened? That double bond is with like rearrangement. That's what happens there. You can see that double bond is going to move and adjust. At that methyl is going to lose one hydrogen. That's the rearrangement we have there. So at the end, under esterification reaction, you form the ester. What happened? The place of that place is that point of that double bond is still the place. That's where something is happening. So that double bond is going to also come out again and close the ring. There will be another rearrangement. As you can see, the ring will be closed, and our ester functional group, that's CH3COO, will be attached. That's why we form our isomyl ethanoates, making it an ester. Under hydrolysis, that bond of ester, that's carboxylate bond, is going to cleave out, and we're going to have an alcohol, then which oxidizes to form a camphor. So you should be able to know how this camphor is synthesized. Go through it and see if it makes sense. So, okay, the last slide should be the next slide on this. Now, this compound is pulegon. This pulegon is a compound that can be hydrogenated. Hydrogenation of pulegon remember, hydrogenation is adding hydrogen to an unsaturated compound in the presence of platinum or palladium. So in this hydrogenation, we're using hydrogen, using palladium with carbon, okay, as the catalyst. So when hydrogenated, pulegon is going to form cis-dihydropulegon and trans-dihydropulegon. Okay, so these cis and trans can be equilibrized using potassium carbonate and ethanol. So when I have my cis dihydropulegon, under potassium carbonate, I'm going to form trans. And when I have my trans, using ethanol, I'll translate to cis. So this is what they call equilibrization. So this compound can be equilibrated using potassium carbonate from cis to trans and methanol from trans to cis. This is pulegon. Remember, we started by pulegon. When hydrogenated, will form cis and trans dihydropulegon, which can be equilibrated using potassium carbonate and methanol. From cis, I can form trans using potassium carbonate. Then from trans, I can transit back to cis using methanol. So ask your question. We're going to start the next class according to your schedule. Just inform me or course rep, discuss with your team and give me the breakdown of your schedule so I can work with it. So I can also factor other courses I have to teach the undergraduate, like lab and other courses. So let me know your schedule. Since it's online, it's perfectly well. And if evening works for you as being online class, let me know your evening time. Let it be a time that everybody will be focused. I don't want you're in the class and you're in the office. I know that you guys are mature students looking for money. So let me know time that works for you. And even if it's weekend, we select some weekend that is okay for everyone. So at the end of each of the classes, we know that we benefited. We don't just waste our data. And remember, after the class, you can also go ahead and listen to this recorded version of this class online. Okay, so let's take the classwork, which will be submitted on Google Classroom. I'm going to share the link of the classroom. Question number 1, please be writing it down. Course rep, at the end of the class, please share this question on the platform and make sure I'm added to the platform so I can also enlist it on the Google Classroom. So question number 1. What is the backbone of terpenoid? Or what is the starting material for terpenoids? What is the basic starting material for terpenoids? Question number 2. There are list the classes of terpenoids, the number of isoprene units, and 2 examples each. The classes of terpenoids, the number of isoprene units, and 2 examples. Those examples must come with structures. That's number 2. Number 3. Show using detailed structures the synthesis of camphor. Using detailed structure and equations, the synthesis of camphor. That's the 3 questions. Share it on the platform so I can list it on the Google platform. The assignment is meant to be submitted before the next class. If the next class is to be Wednesday, you're supposed to submit the assignment Tuesday by at least 11:59 p.m. So when it's 12 a.m. of Wednesday, anybody that submits the assignment, it will not be used for the person. So make sure you follow. Victoria, share these assignments for people that couldn't get it so they can get it. Number
Okay,
1
ma.
is the hope you got all the assignments, right? All the class work.
I got them.
Did you get all? What's question number 1?
What is the backbone of terpenoids? What is the basic starting material for terpenoids?
Okay. So make it the basic starting material for terpenoids.
Okay, ma.
Number 2.
List the classes of terpenoids, the number of isoprene units, and 2 examples with their structures. 2 examples each
Okay.
with their structures.
Okay, number 3.
Show using detailed structures and equations the synthesis of camphor.
Okay. Thank you very much. So share it. I hope there's no question from anyone. Thank you very much for coming. So you guys are 7 in number that are doing this course, right? Is anybody missing in attendance?
Yes, I don't know. For organic students, we actually 4 number, but some people are taking it as a late fee. So for now, we don't know if they are going to be adding more students or not.
Okay. So let it be shared on the platform. Nobody should miss the class. Attendance is very important, especially because we are dealing online. Okay. All right.
Okay.
Thank you very much for coming.
Thank you,
Okay, see you in
ma'am.
the next class.
Yes,
Thank
ma'am.
you. See you guys in the next class.
Yes, mommy.
Bye.